Have you ever wondered what space-time is? Well, you're not alone. It's a concept that has puzzled and fascinated the greatest minds for centuries. Space-time is the four-dimensional fabric of our universe, a stage where the cosmic ballet of stars and galaxies unfolds. It's a concept that revolutionized our understanding of space and time, merging them into a single entity. In this video, we'll take a closer look at this intriguing concept, from its roots in Einstein's theory of relativity to its implications for our understanding of the universe. We'll delve into the curvature of space-time, the phenomenon of gravitational time dilation, and the mysterious entities known as wormholes and black holes. And we'll explore the expanding universe, a key aspect of the Big Bang theory. Understanding space-time might seem daunting, but don't worry, we'll take it one step at a time. So buckle up and get ready to embark on a journey through the fabric of our universe. So, what is space in the context of the universe? Well, let's dive right in. When we think of space, we are referring to a three-dimensional expanse where all objects, events, and even we ourselves exist. Imagine it as a vast, infinite stage where the grand play of the cosmos unfolds. But how do we perceive this space? It's through the distances between objects or points within the universe. Whether it's the gap between atoms in a molecule or the light years separating galaxies, space encompasses it all. It's the canvas upon which the stars are painted, the fabric that cradles planets, and the silent void that allows the music of the cosmos to resonate. It's all around us and within us, an intrinsic part of our reality. Space is not just emptiness, it's a fundamental element of the universe. And this space forms the stage upon which the universe unfolds. Now let's turn our attention to time. Time, ever elusive and often misunderstood, is the dimension that puts events in a sequence from the past, through the present, and into the future. Imagine a long, winding river. The water that has flowed past represents the past. The spot where you're standing signifies the present, and the water yet to flow symbolizes the future. Just like a river, time flows, creating a framework that allows us to understand the sequence of events. It is through time that we can comprehend the succession of day and night, the changing of seasons, the ticking of a clock, or the aging of a living being. Time is the invisible thread that stitches together the tapestry of the universe, linking one event to another. It's the rhythm to which the cosmos dances, the silent beat that orchestrates the unfolding of all events. Time allows us to understand the unfolding of events in the universe. Albert Einstein revolutionized our understanding by proposing the unification of space and space-time. As we journey further into the cosmos, we encounter a new realm, one where space and time are not separate entities, but rather a fused four-dimensional continuum. This is the world of space-time. Einstein's theory of relativity shattered the conventional understanding of separate space and time dimensions. Instead, he proposed a unified model where these two concepts intertwine to form the fabric of our universe. Picture this. Instead of moving along separate paths, space and time flow together, creating a river of cosmic existence. This revolutionary idea changes the way we perceive the universe. It is no longer a stage where events unfold over time, but rather a four-dimensional expanse where events occur within space-time. So, brace yourselves as we delve deeper into this fascinating concept. Welcome to the world of space-time, where space and time are intertwined. Let's delve into the fascinating concept of the curvature of space-time, a groundbreaking idea put forth by Albert Einstein in his theory of general relativity suggests that mass and energy can actually distort this four-dimensional fabric we've been discussing, and this warping is what gives rise to the force we know as gravity. You see, according to Einstein, space-time isn't a static stage upon which the universe performs. Instead, it's a dynamic entity, bending and twisting in response to the mass and energy within it. Imagine for a moment a trampoline surface. If you place a heavy ball in the center, the surface warps, dips, and curves in response. Now, if you roll a smaller ball onto the trampoline, it will naturally follow the curved path created by the larger ball. This is a simplified way of understanding how space-time curvature works. In the cosmos, massive celestial bodies like stars and planets act like that larger ball on the trampoline. They cause a curvature of space-time around them, and it's this curvature that guides the motion of smaller objects nearby. That's why Earth orbits the Sun, why the Moon orbits the Earth, and why astronauts in the International Space Station experience weightlessness. They're all following the curved paths dictated by the space-time around them. But here's where things get even more fascinating. This isn't just about the path of physical objects. Even the path of light itself is influenced by the curvature of space-time. This is why light from distant stars appears to bend when it passes close to a massive object, a phenomenon known as gravitational lensing. This realization revolutionized our understanding of gravity. It's not simply a force pulling objects downward, as Sir Isaac Newton proposed. Instead, gravity, as we understand it today, is a manifestation of the curvature of space-time caused by mass and energy. In essence, gravity is the warping of the universe's stage itself. And that's the beauty of it all. Gravity, as we perceive it, is a consequence of the curvature of space-time. Did you know that gravity can affect time itself? This isn't science fiction, but the real-world phenomenon of gravitational time dilation, a fascinating aspect of Einstein's theory of general relativity. Imagine you're standing on a planet with a strong gravitational field. Your wristwatch, the beating of your heart, even the thoughts in your brain, all would seem normal to you. But if someone were to observe you from a region with a weaker gravitational field, they'd see your actions happening at a slower pace. Your watch would appear to tick more slowly, your heart would seem to beat at a slower rate, and your thoughts would appear to unfold more gradually. This is because the strong gravitational field of the planet is actually warping the fabric of space-time around you, causing time itself to pass more slowly. It's a mind-bending concept, but one that's been proven with precise experiments. In the realm of space-time, gravity can slow down time. Let's venture into the intriguing territories of wormholes, black holes, and the expanding universe. General relativity, Einstein's groundbreaking theory, not only reshapes our understanding of space and time, but also predicts some truly fascinating phenomena. One such prediction is the existence of wormholes. These are hypothetical tunnels in space-time, almost like shortcuts that could potentially connect far-flung regions of the cosmos. Imagine being able to step through a door in your living room and emerge on the other side of the galaxy. That's the allure of wormholes. However, it's important to note that these are purely theoretical constructs at present. Our technology is yet to catch up with the audacious predictions of our mathematics. Then, there are black holes, the enigmatic regions where space-time curvature becomes so extreme that nothing, and I mean absolutely nothing, not even light, can escape its gravitational pull. These cosmic monsters are not just theoretical predictions anymore. We've observed their effects and even managed to capture an image of one. They're the ultimate testament to the power of gravity and the warping of space-time, but let's not stop there. When we look up at the night sky, we're not just seeing stars and galaxies. We're witnessing the stretching of space-time itself. Observations of distant galaxies have revealed that they're moving away from us. And it's not just a simple drift. Every galaxy is moving away from every other galaxy. This is not because they're physically moving through space. It's because the very fabric of the universe, the space-time, is expanding. This expansion of the universe is a key aspect of the Big Bang theory, which describes the origin and evolution of the universe. It's an ongoing process, happening right now as you're listening to this. Space-time continues to stretch, carrying galaxies away from each other as part of the universe's expansion. The cosmos is growing, minute by minute, second by second, at an unimaginable scale. Space-time continues to stretch, carrying galaxies away from each other as part of the universe's expansion. We've journeyed through the fabric of the universe, exploring the concept of space-time. We've unraveled the three-dimensional expanse we call space, where all events and objects occur. We've navigated through time, the dimension that sequences events from past to present and future. We've dived into the heart of Albert Einstein's groundbreaking revelation that space and time are not disparate entities, but are woven together into the four-dimensional continuum known as space-time. We've peered into the curvature of space-time, understanding how mass and energy warp its fabric, creating the phenomenon we perceive as gravity. We've explored gravitational time dilation and how time itself is influenced by the strength of gravitational fields. We've ventured into the mysterious realms of wormholes and black holes, and journeyed across the expanding universe. So, the next time you gaze at the stars, remember, you're not just looking through space, but also time.